Okay, good afternoon, everyone. My name's Callum. I lead AIM, and I'm going to talk to you today about how we have a solution for managing the absolute worst of the worst. So our typical remit is we speak to councils and authorities about what they're really concerned about. These are end-of-life structures or these are critical components. So again, just working on structures, critical components, and making sure we do this in a cost-efficient way and extend the lifespan of those structures. So the challenge we're up against, aging assets. We've got a lot of stock in this country, which is built in the sort of 60s, 70s. That's all coming to a head. Really challenging to look after. We're doing this against shrinking budgets, which is to say, I don't know if anyone's noticed, but the UK isn't doing so hot right now. So everyone's feeling the pinch, including maintainers. And there's obviously zero room for error. There's no forgiveness for a bridge falling or a critical component failing. So we need a solution which is able to meet these challenging demands. So how do we tell if an asset has degraded? Well, this happens in all shapes and sizes, whether you're working with bridges, drainage, larger infrastructure, bearings. They all have unique ways of degrading, asset to asset, design to design. So typically what people do when you get to this sort of stage is they take some level of measurement and you end up with something that looks like this. You might have a sensor to it. It might be a manual process. You could be measuring pressure in a pipe, displacement of a bearing. It doesn't really matter. You're taking some sort of sensor data. The thing that's really hard here is how do you know if this is safe or not for your asset? This is a really tricky problem. You can look at this and say, well, there's not much variation, but it's a subtle sign of degradation in there. It's really hard to tell. And if we could find those, then it means we could solve smaller problems earlier. This is where machine learning comes in. Machine learning is able to overlay a baseline of what that structure should be doing at any point in time with precision. And suddenly I've got a different use case. So that sense behavior now, I can compare it against this baseline, and I know with complete confidence that this is in good stead. And if I'm unnecessarily spending maintenance budgets on this, it's not necessary. This component is fine. So what do? We're the first company to use AI to actually understand structural behavior. That's a massive breakthrough. This is not learning to copy-paste data. This is actually, can I create the perfect digital twin to inform maintenance and budgets? The rationale for doing this is if we can achieve this kind of insight, this can drop maintenance budgets by up to 65%. We can also extend the lifespan of structures by up to 5 years. So we've got projects running for that long. These are structures that have been given an extra lease of life, and improve safety by up to 10-fold. So some assets, this is 40, but we're comfortable with 10. So the real question isn't what's visibly wrong. When you have a technology like this, it's what's coming and what's driving it. So here's an example for a project. This is something that we've done with Blackpool Council. And they're in this position where you're looking at this data and you go, again, how do I know if this is safe or not? It's really difficult to tell. I've got a sensor at the top, sensor at the bottom, data at the top, data at the bottom. How do I know if this is degrading or not? Well, this is where AI is able to just overlay in green exactly what that structure should be doing. And suddenly at the top, I can see this absolutely fantastic condition in that component. Those green and red lines match exactly. And below that, they actually diverge. And what you're looking at, sort of in that bottom left there, where they start to diverge, is the beginning of a defect. Now, that's never before been possible. So you're looking at the defect at its earliest possible stage. If we can intervene here, it's much cheaper and preserves the lifespan of the structure. A little word on accuracy, because that's great to claim that, but we just keep these in here just to show that there are really important statistical bounds showing that what we're doing is valid, and we achieve the sort of 99% accuracy in predicting future behavior. So just a bog standard table there to show you what the accuracies are, lots of 99s, lots of 98s, and then again, structure that we did for Ian Large, showing the learning process and how the machine learning day by day is understanding the structure more and more. And you can see it takes about, we sort of say 6 months to see a full characterization of the structure, but you can get utility after a sort of 15 days or so. And what we're doing here is we're not learning to copy-paste data. We're learning the underlying physics that govern your structure. So all that complexity we handle, we just show you guys at the earliest possible moment when something's wrong so we can make really good plans around it. There's other couple of tools which fall out of this, which we've give to engineers, which is really useful. So again, another defect here, you can see a plastic offset. So that blue line is what the structure is doing. That green line is what it should be doing. There's an offset. The question is why? Okay, we know about this early, but why? We also pull in environmental data as well. So this is things like your traffic, river levels, environment. So if you have a defect, we can use this to start to understand why has this occurred, what can we do to fix it, what can we do to increase resilience. So if you look at this chart below, it shows me that defect is occurring because of changes in river level. So I know if I want to take some preventative action, that's what I should target. This is extensible to portfolio. So obviously people here have got, tens, hundreds, thousands of structures. This works across a portfolio. So if you want to understand where your budget should be spent with precision, this is a really good tool for that. And you'll notice on several of the assets there, we give them a percentage, and that's actually plotting out the degradation curve of that asset. So you can watch that asset degrade over time and understand in real time which one's degrading fastest and where your focus should go. So where can we help? Well, anywhere there's data. So this is really us asking you, tell us where your data is, and we would like to propose to you how we can help. Please do come and see us. We're sort of just in the corner there underneath the entrance door B sign up the top there. But we work across, if it's infrastructure, bridges, tunnels, footbridges, building and construction works, energy, utilities, drainage networks. Please do get in touch. We're very well adopted now, thanks to some great work by my colleagues and team. We're continuing to grow and hoping to work with more councils like yourselves. A couple case studies just to show you the actual real world implications of this. So this was a critical structure on the M4, and this bridge was found to be past its fatigue lifespan. This was a sort of 8-figure replacement was planned. This was going to have to be closed at the drop of a hat. What happened is monitoring went on, and we took that data, analyzed it, and showed that actually this structure had life left in it, and as a result, it's still open today. So this has saved an 8-figure replacement, given safety, better safety targets to the operators, and most importantly, kept the south of Wales open. And we got a good quote. Another one, incredibly complicated structure here, total hodgepodge of design, lots of critical elements, similar story, but this time there's a traffic intervention on it to the tune of 100-something grand a year. Really important secondary costs that build up from managing this. What we're able to do is, again, go in there with machine learning, understand the structure, show that in fact the structure was behaving totally okay. And we were actually able to work with the council and help them to remove contraflow, increase traffic flow on the bridge, and actually start to remove weight restrictions. And, importantly, we got rid of that 100K a month, 100K a year traffic intervention. So savings in tenfold alone, just on traffic management there. Couple other case studies just to show you some of the other things that drop out for different users. Dynamic alerts for safety. So if we know what the structure is doing, we can sort of build a set of dynamic alerts and then make sure the structure behaves in those parameters. This means if you've got safety concerns of those critical elements, you'll know far in advance of what's normally possible. Degradation plots, this is one of my favorites. So this, you'd hope there's no degradation. If that was the case, this would sort of stay along zero. If you've got a trend, you're looking at this is degrading at X microstrain, X millimeters a year. So really helpful to target or understand issues between structures. Vulnerability heat maps, if you've got multiple sensors in a network of drainage, or it's piers on a bridge, or it's half joints or whatever you have, we can actually show in red where that issue lies. And that means if you've got inspection teams, they can go straight to the issue instead of, and understand when they should be going and looking for what conditions, instead of going and sort of doing the routine annual 6-month, 2-year inspection. And then there's long-term forecasting. So if people, our clients want to stay ahead, they can use long-term forecasting to sort of get a view of what's going to happen over the next 1 to 5 years. So for us, it's a really important leap in capability. This is actually understanding what your asset is doing and what are good remedies to it. So first and only algorithm of its kind. We'd love to speak to you guys about what data you have and how we might be able to help work on those data sets with you guys. So again, this is on data that's already being collected. We're working with councils, and we'd love to work with you guys too. Again, under that sort of B stand, do come have a word. So thank you very much.